Have you ever driven alongside a semi-truck on the highway and noticed one or even two entire axles literally floating above the asphalt without touching the ground? You might have wondered why they're like that. Why wouldn't all the wheels touch the road, as you'd logically expect? Don't worry, because in this video, we'll explain in detail why some truck tires don't always touch the ground. We'll also give you a deep dive into how truck axles work, the different types, and how they determine exactly what a truck can or can't do in various situations. But before we solve this engineering mystery that many drivers never truly understand, if you're fascinated by heavy vehicles and the engineering behind them, hit the like button and subscribe for more content that reveals the secrets of the transportation industry. Now, let's start uncovering the secrets behind this phenomenon. A deep dive into how truck axles work. An axle is a robust metal rod made of high-strength steel that connects two wheels and supports the weight of an entire vehicle that can weigh many tons. Axles are absolutely essential components of any vehicle, especially heavy-duty trucks carrying massive loads. They are connected to the wheels by heavy-duty bearings that allow for smooth rotation even under extreme weight. When the engine spins the transmission with its generated power, the transmission rotates the longitudinal drive shaft that runs the length of the vehicle. This spins the differential, which distributes power between the wheels, which in turn rotates the axle shafts with precision. Then the axles turn the wheels, propelling the vehicle forward or backward according to the driver's needs. It's an elegant yet extremely robust mechanical system. There are two main types of truck axles you need to know to understand these configurations. The steer axles are typically located at the front of the truck and allow the driver to steer the vehicle using the hydraulic system. Sometimes they are also found at the rear to create a tighter turning radius in special European configurations. Then there are the drive axles, located at the back of the truck, which provide direct power to the wheels from the engine, or at the front in the case of all-wheel drive for extreme terrain or weather conditions. That's in addition to steer and main drive axles, there are two other variants found on specialized trucks. Tag axles are located at the rear of the tractor and provide additional structural support for heavy loads that exceed normal design capacities. And lift axles, often strategically placed between the drive axles, can be raised or lowered hydraulically or pneumatically to improve fuel efficiency or traction based on specific operational needs. Fun fact number 1. The first truck with lift axles was developed in Europe in the 1970s when axle weight regulations became stricter following studies on infrastructure damage. Manufacturers needed a clever way to comply with new laws without reducing the payload capacity that generated profit. Thus, this ingenious solution was born, and it's now a global standard in the heavy transport industry. But what's the point of driving with an axle that isn't in contact with the abrasive road? Well, there are actually multiple technical and economic reasons for this that go beyond what meets the eye. Let's start with better grip and traction in hazardous conditions. Lift axles can be lowered when the truck is fully loaded to its maximum allowed weight, distributing the weight more evenly across all available axles. This smart increase in weight over the tires dramatically improves traction and grip, especially in dangerous weather like heavy rain, deep snow, or slippery ice where it's easy to lose control. For instance, Volvo has a smart tandem axle lift feature to improve grip when needed in critical situations where traction can save lives. Ground pressure and infrastructure protection. When a truck is fully loaded, it can exert significant and damaging pressure on the road surface, causing expensive damage or sinking into softer ground like dirt. By lowering the extra axle to spread the weight, the total load is distributed more evenly, drastically reducing the ground pressure per square foot. This minimizes wear and tear on the roads and public infrastructure that we all pay for with our taxes. This is especially important on older bridges that have strict weight limits for structural reasons. Fun fact number 2. A fully loaded truck with all axles properly lowered can exert less pressure per square inch on the asphalt than a woman walking in pointed high heels. But the physics of weight distribution is fascinating and counterintuitive to many who don't study engineering. Load adjustments to comply with complex regulations. Lift axles allow experienced truckers to dynamically adjust the load distribution as needed. This is particularly important for meeting varying weight regulations that change by region, as different jurisdictions and countries have specific limits on individual axle weights measured at weigh station. By strategically raising or lowering lift axles based on the load, the driver can ensure the weight is distributed evenly within established legal limits. This helps avoid costly fines in the thousands of dollars and legal issues that could result in a suspended license. Then there is fuel efficiency and massive operational savings. Using extra axles on a truck consumes more fuel due to increased rolling resistance and friction with the asphalt. And by lifting axles when they aren't needed, like when the truck is empty or carrying a light load, fuel efficiency can be significantly improved. This reduces operating costs and minimizes the environmental impact of freight transport. In a large fleet of hundreds of trucks, this represents monthly savings of thousands of dollars in diesel. Fun fact number 3. A truck operating with its axles lifted when empty can save up to 15% on fuel compared to having all axles down unnecessarily. In a truck that travels 125,000 miles a year, this means thousands of gallons of diesel saved and tons less CO2 emitted into the atmosphere. Legal mandates and strict axle weight limits. Lift axles play a crucial role in complying with weight standards imposed by local transportation authorities. Overloaded vehicles can incur severe fines. Raising or lowering axles allows drivers to adjust their truck's configuration to stay within legal weight limits. In the United States, the federal limit is 34,000 pounds per tandem axle. In Europe, regulations vary by country, but are equally strict to protect the roads. Reduced maintenance and long-term operating costs. Lift axles, like any mechanical component, experience wear and tear over time from continuous use in extreme conditions. However, lifting them when they aren't in active use reduces the mileage and stress on these axles, significantly extending their lifespan over the years. This leads to lower maintenance costs and less frequent repairs at specialized shops. Plus, tires wear down less since they aren't constantly in contact with the abrasive road. A high-quality truck tire can cost between $500 and $1,000. Extending their life is economically crucial for a company's profitability. Fun fact number 4. A full set of tires for a multi-axle truck can cost over $10,000. By using lift axles strategically, transport companies can extend tire life by up to 30%, representing massive savings for large fleets. Improved braking safety and vehicle stability. When a truck is fully loaded, having the extra axles down provides more stopping power because more tires are in contact with the road. This means the truck can stop more effectively and efficiently in emergencies, reducing the risk of accidents caused by inadequate braking or dangerously long stopping distances. When properly lowered, lift axles increase the truck's stability, especially when taking sharp turns or during sudden emergency maneuvers. The extra tires help distribute weight evenly and provide better grip, reducing the likelihood of rollovers or dangerous loss of control that can be fatal. How lift axles work technically in detail. Lift axles are generally connected to the truck's air suspension system via heavy-duty industrial airbags. They can be controlled via a switch in the truck cab, easily accessible to the driver. When the switch is activated, compressed air is pumped into the airbags, which lifts the axle vertically off the ground. When the switch is turned off, the airbags deflate in a controlled manner, lowering the axle until the wheels firmly touch the ground. The axle is raised when the truck is empty or carrying a light load. This improves fuel efficiency by reducing friction between the tires and the road. The axle is lowered when trucks are carrying a full, sheer heavy load. This improves stability and handling by increasing weight distribution across more contact points. Lift axles are commonly used on long-haul trucks, dump trucks, and heavy construction vehicles. Fun fact number 5. Some modern trucks have intelligent automatic systems that detect payload weight using electronic sensors and adjust the lift axles automatically without driver intervention. These smart systems can make millisecond decisions based on weight, speed, road conditions, and even weather through real-time data. There are several lift axle configurations available depending on the truck type and its specific use. The front lift axle, or pusher axle, is located just behind the main steer axle. It helps distribute the weight of the heavy engine and the driver's cab. The rear lift axle, or tag axle, is located behind the main drive axles. This is the most common for general freight. The intermediate lift axle is placed strategically between two drive axles. Common in heavy-duty setups for extreme loads, the choice depends on the type of load, regular routes, and specific local regulations. Important considerations for professional drivers. Experienced drivers know exactly when to raise or lower axles based on the situation. Keeping them down while empty wastes expensive fuel. Keeping them up while loaded can result in fines or suspension damage. Many companies have specific policies on when lift axle use is mandatory. Some countries require all axles to be down on certain roads regardless of weight for safety reasons. The future of lift axle technology is evolving. Technology is constantly advancing in the industry. New systems include real-time weight sensors per axle, GPS-based automatic adjustments based on location, and full integration with fleet management systems. Some experimental prototypes even adjust axles individually based on detected curves and inclines. Efficiency will keep improving through sensor technology and artificial intelligence. So why don't some truck tires touch the ground? Because some trucks have ingenious lift axles that allow an axle to be raised when it's not needed for the current load. Because when a truck is running empty or light, it allows for significant fuel savings and less wear on expensive tires that cost thousands. Because when the truck has to travel with more weight, the axles can be lowered to decrease ground pressure and prevent damage. Because lowering the axles allows for a higher total legal payload while staying compliant with regulations, and it keeps the vehicle within the strict legal framework of each jurisdiction, improving road grip and overall safety while reducing accidents. Therefore, an additional lift axle is a versatile tool for a truck hauling variable loads daily. But the story of lift axles doesn't end with mechanics and regulations. But there are dimensions to this system that even professional drivers with decades of experience might not fully know. Let's start with something that happens at every weigh station in the world. When a truck stops on a scale, the inspector doesn't just measure the total weight of the vehicle. They measure the weight on each individual axle. This is where the exact position of lift axles can be the difference between passing the inspection or getting a fine. That, in some countries, it exceeds $10,000. The same total weight distributed slightly differently can pass or fail legal limits at the same time. An experienced driver who knows their load can adjust the position of the axles millimeter by millimeter to satisfy all axle limits simultaneously. It's a form of applied arithmetic that isn't taught in driving schools. It's learned through years on the road and at the scales. And the environmental impact of smart axle management is another aspect that deserves attention. A company operating 500 trucks with a systematic policy for lift axle use can reduce fuel consumption by a percentage that, when multiplied by the annual mileage of the entire fleet, represents millions of dollars in savings per year. These savings translate directly into tons of CO2 not being emitted. Turning something as simple as raising or lowering an axle into one of the most accessible tools for reducing transport's carbon footprint without needing to replace fleets or invest in alternative propulsion technologies. The differential wear of tires on lift axles also creates specific problems that maintenance managers know well. Tires used intermittently go through repeated thermal cycles, heating up during load phases and cooling down when the axle is raised. Over time, this alters the internal structure of the rubber compound in ways that aren't visible externally, but reduce its strength under load. Tire manufacturers have developed specific compounds for these conditions, with a different chemical makeup than tires on permanent load axles, even if they look identical. The immediate future of these systems points toward deep integration with digital technology. Current telemetry systems already allow fleet managers to monitor the status of every lift axle in real time, receiving alerts for early failures and scheduling maintenance before a breakdown happens on the road. Autonomous truck prototypes include axle management systems that adjust configurations with a frequency impossible for a human driver, responding to changes in grade, pavement variations, and real-time weight distribution predictions. And the long-term vision is a truck that always has the exact optimal axle configuration, without a single human decision needed. What started as a pragmatic solution to stricter regulations in the 1970s has become one of the most sophisticated systems in heavy transport. The next time you see an axle floating over the asphalt, you'll know it's not an oversight or a breakdown. You're looking at decades of engineering, physics, and technology condensed into a mechanism that moves with millimeter precision at the exact moment it's needed. If you find this kind of content as fascinating as we do, subscribe to the channel and turn on notifications. Every week we post videos revealing the hidden engineering behind the machines and systems that move the world. Most people see them every day without understanding how they work. You are no longer one of them.